Data interpretation and logical reasoning. The part data interpretation is basically understanding data. The data can be represented in many different forms or methods. Like the data can be represented using a line chart, bar graph, tables, or many different forms. We will go through each one of them separately. First, let's look at bar graph. So let's take a look at the bar graph that's in front of us. The bar graph represents trade in rubber from 2006 to 2017. The year is marked in the x-axis and rupees in crore is marked in y-axis. So each of this rectangle or each of this bar represents exports and imports. Exports is represented by this black bar and imports is represented by this white one. Now for example, in 2006 the exports was 280 and import was 220. And in 2007 the exports was 280 again and import was 240. As you can see, the first step that we are going to do is to convert this bar graph into a table. Here I have filled up the table. I have represented year here and exports and import. So it is very important that you draw this table so that it's easier for you to do the problem as we move forward. There are 5 questions in this session, so having a table will help you solve this question much faster. Question number 1. Average annual exports for the given period 2006 to 2017 was approximately. So to find the average, all you have to do is to add all the exports and then divide it by the number of years. The number of years is from 2006 to 2017 it is 12. So let's add the exports 0 and here it will be 2, 3, 5, 6, 9, 17, 25, 25, 2, 12 2s here. So 12 2s 24 plus 2, 26, 2650. Total exports is 2650. 2650 divided by 12. When you divide it, you will get we get remainder as 2, 2, 5, again 2. Remainder is 1, 1, 0. So it becomes 0.100. It's 12 into 8, 220.8. So the question was approximately option B, 220 crore is the closest answer. So option B is the answer. Question number 2. The percentage decline in exports during the period 2006 to 2011 is more than the percentage decline in exports during 2012 to 2017 by approximately. So let's first find the percentage decline in exports during the period 2006 to 11. So in 2006 the exports was 280 and in 2011 it is 220. So there is a decline of 280 minus 220, 60 divided by 280. 280 is the value of export in 2006, so that's the value you have to take, into 100. 600 divided by 28. 28 2 5 6 4 0 1 minus 28 12 120 28 5 140 28 4. So 21.4. And the second part of the question asks is more than the percentage decline in exports during 2012 to 2017. 2012 to 2017. So in 2012 it was 210. It declines to 200. So there's a difference of 210 minus 200. 10 divided by 210 into 100. So that becomes 100 divided by 21. So 21 into 4 is minus 84 divided by 16.160. 21 into 7 is 714. So 4.7 is the answer for the second part of the question. So now we have to find the difference in percentage decline between 6 to 11 and 12 to 17. So all we have to do is 21.4 minus 4.7, which will be equal to 16.7. The nearest answer is option A, 16.5. So option A is the answer. Now we move on to question number 3. The maximum difference between imports and exports is. So you look at the options and you can see 60, 110, 120. So 120 is the highest in the options. So when we look at the table, look for a difference that is up to 120. So you go from the first one, 60 to 200, 310, 110, that's the highest right now. You get 110 again, 320 minus 210 is 110. You go down and you find it. 320 minus 200 is 120. So 120 is the maximum in option, so go for it. Option C is the answer. You don't have to search anymore. So I have cleared some part to write the balance of trade, balance BOT, balance of trade. So from 2007 to 2009. So export minus import in 2007 is 40. In 2008 is minus 30. In 2009 it is minus 70. Next in option D, 2010 to 2012. So minus 110, minus 70, minus 110. Next is option C, 2014 to 2016. It is minus 120, minus 110 and minus 30. And option B, 2015 to 2017, 15 and 16 we have already written. 2017 is minus 40. Now we have found the balance of trade, that is export minus import, for each year. You must have noticed that in the question it is given as 3 year blocks and you are asked to find the average. We don't have to find the average because all of these are 3 year blocks and all of them will be divided by 3. You will get the same answer. So option A, 2007 to 9, which means you have to add 40, minus 30, minus 70, you will get minus 60. So you can look through each of the options and confirm yourself. I think you already got the answer. If you look at the options, 2010 to 2012 is the largest. Minus 110, minus 70, minus 180, minus 290. So you can check for others. None of this is greater than minus 290. So 2010 to 2012 has witnessed the largest average negative balance of trade. So option D is the answer. Now we come to the last question of the set, question number 5. The percentage increase in imports over the previous year is maximum during. Option A, 2009 to 2010, then there is an increase of 30. So 30 divided by 280 into 100. Now we come to option B, 2010 to 2011, there is actually a decrease. So we don't even have to calculate this value. So we go to option C, 2013 to 2014. In 2013 it was 300, it goes to 320. 320 minus 300, 20 by 300 into 100. Option D, 2008 to 2009. In 2008 it is 260, it increases to 280. So 280 minus 260, 20 divided by 260 into 100. So we have right now 4 values here. Out of this, when you compare 20 by 300 and 20 by 260, you can see that the denominator is less. Out of this, when you compare 20 by 300 to 20 by 60, you can see that there is a difference in denominator. The numerator remains the same, but the denominator is less here. So you must know that as the denominator reduces, the value of the fraction increases. Since the value of 20 by 300 is less than 20 by 260, we avoid the option 2013 to 2014. Now it is between option A and option D. So option A is 300 divided by 28 and option D is 200 divided by 26. So before proceeding further, you can see that 28 into 10 is 280. So this value is greater than 10 and 26 into 7 is less than 200. So this value will be somewhere around 7 plus. So option A, 2009 to 2010 is the answer here. The set I have chosen is a little bit hard, so you need to concentrate properly to understand the question. So let's go to the DILR set. This is an example of a composite bar graph. A composite bar graph contains a more number of data values. For example, in this graph in 1998, we have 2 different values. The blue represents Purana and this reddish brown bar represents Naya. So in a single year, it has 2 different data values. It can increase to 3 or 4, but the approach to solve the question will remain the same. Now let's try to solve this question. Purana and Naya are 2 brands of kitchen mixer grinders available in the local market. Purana is an old brand that was introduced in 1990. We don't have the data from 1990, only from 1995, while Naya was introduced in 1997. So that is the reason why there are no reddish brown bars in 1995 and 1996. For both these brands, 20% of the mixer grinders bought in a particular year are disposed of as junk exactly 2 years later. I will explain this point properly, but let's figure out what are the data items that is represented in the graph. So in the final sentence of the question, the following figures show the number of Purana and Naya mixer grinders in operation from 1995 to 2000 as at the end of the year. So for example, in 1995, there are 120 number of Purana mixer grinders that are in operation. It is not the number of new purchases made in 1995, but it is the number of mixer grinders in operation. If you don't understand the graph properly, that is okay. We will convert it into a table. Then you will get the whole picture. In this table, there are two columns, Purana and Naya. Let's write down the year at the left hand side of the table. 1995, 96. 97, 98, 99, 0. Now let's transfer the data from the graph to the corresponding years in the table. In the year 1995, there is 120 mixer grinders from Purana in operation. So at the end of 1995, which means on the 31st of December 1995, there are 120 mixer grinders from Purana in operation. At the end of 1996, it is 162. At the end of 1997, it becomes 182. 222, 236, 236. Now we come to the next column, which is Naya. The data for Naya starts from 1997. So on 31st of December 1997, by the end of year 1997, there are 30 Naya mixer grinders in operation. Before proceeding, let's see another thing here. What does this 30 represent? Actually, the value 30 represents the new purchases that happened in 1997 because Naya started only in the year 1997. So before proceeding, let's make 3 columns under each of these. For Naya, there is number of mixer grinders in operation O. Then we have number of new purchases, NP, new purchases. And at the end, there are number of defective mixer grinders, DEF. So same here for Purana, O, NP, and defective. So let me explain what each of this represent. The third line of the question reads, for both these brands, 20% of mixer grinders bought in a particular year are disposed of as junk exactly 2 years later. Keep this point in mind while we do the rest of the question. So for the year 1997, there are 30 overall purchases for the brand Naya. But you have to also remember that the brand Naya came into existence in the year 1997, which means O is equal to NP. The overall purchase in 1997, which is 30, is also equal to new purchase. NP is also 30. I hope you understood this point. Now from the third line of the question, for both these brands, 20% of mixer grinders in a particular year are disposed of as junk. New purchases in 1997 is 30. 20% of 30 is 6, which means 6 of the mixer grinders which were purchased by the end of 1997 will be disposed of by the end of 1999. So by the end of year 1999, there will be 6 defective or disposed of. Okay, D represents defective or disposed of. So out of the 30 purchases in 1997, 6 will be disposed of. And for the year 1997, because there are no other purchases made before 1997, the defective or the disposed of number is 0. So now we move on to 1998. Now it has become 80 active number of mixer grinders for Naya. Out of this 80, 30 is from 1997 itself. So the new number of purchases is 80 minus 30, 50. By the 20% rule we have in the question, out of the 50 new purchases made in 1998, 10 of them, which is 20% of them, will be disposed of in the year 2000, 2 years later. So we write 10 here. At the end of 1998, the number of disposed of mixer grinders will remain 0 because there was no purchase in 1996. Now we come to 1999. There is 1, 2, 4 for overall active mixer grinders. Out of this, 80 is coming from the year 1998. By the end of the year 1990, 6 of them will go out of operation. So 80 minus 6 is equal to 74. Only 74 will remain from the previous years. So new purchases will be 1, 2, 4 minus 74, which is again 50. Now for the year 2000, the number of overall active mixer grinders is 134. Out of that, 1, 2, 4 was from the previous years. From the 1 to 4, 10 of them will be out of operation or will be disposed of by the end of year 2000. So 1 to 4 minus 10 is equal to 114. But the overall number is 134. So the new number of purchases is 134 minus 114 is equal to 20 new purchases. I hope this much is very clear for you. You might have a question. Until now we have not found the number of new purchases for Purana in any of the years. So for example, in the year 1995, we have overall active mixer grinders as 120. But we don't know how many of them were new purchases because we don't have enough data. That is, only if we knew how many number of new purchases were made in the year 1993, then we could have calculated 20% of that, and then we could have written it over here and calculate the rest of the question. But we don't have that data. So now let's look at the rest of the question. It is known that 10 Purana mixer grinders were disposed of in the year 1997. So now we have an extra data. Let's write that down here. 10 Purana mixer grinders in the year 1997. So here. So what does this number say to you? 20% of whatever was bought in the year 1995 will be disposed of in the year 1997. How many did we buy in the year 1995? 50. Only if we bought 50 new purchases in the year 1995, then only 20% of that, which is equal to 10, will be disposed of in the year 1997. I hope you understood that. Now let's try to find the remaining data under the column Purana. So we know that in the year 1997, there were 10 mixer grinders which was disposed of. So at the end of the year 1996, there were 162 mixer grinders active. During the course of the year 1997, we lose 10 of the mixer grinders. That means we are left with 152 grinders. So the new number of purchases will be 182 minus 152, that is 30. I will explain this again. On 31st of December 1996, we have 162 number of mixer grinders active. During the year 1997, 30 new purchases are made. So that becomes 192. And 10 of the active mixer grinders are disposed of. So minus 10. So we get 182. That is written here. I hope you understood that. So since we got the number of new purchases in the year 1997, we can find 20% of that, which is 6. So 6 of them will be disposed of in the year 1999, 2 years after purchase. So 6 of them in 1999 will be disposed of. Now applying the same logic as 1997, there are 6 mixer grinders which are disposed of in the year 1999. From the 222 units which are active at the beginning of 1999, 6 of them will become defective, that is minus 6. So it becomes 216. And then during the course of the year 1999, 20 new mixer grinders are bought by the customers. So that becomes 236 and we get this value. So the number of new purchases in the year 1999 is 20. Now applying the same logic, you can find that in the year 2001, 20% of 20, which means 4 of the mixer grinders active will be disposed of. We don't have to do that. Now we have found out as much data as we can from the graph. So let's look at the questions. Question number 1, how many Naya mixer grinders were purchased in 1999? So in 1999, number of Naya mixer grinders will be 50. So option B is the answer. Question number 2, how many Naya mixer grinders were disposed of by the end of 2000? You have to be careful here. They are not asking for the number in 2000, but they are asking for the total number by the end of 2000. So you have to count 10 plus 6. So 16 is the answer. Option B, 16. Question number 3, how many Purana mixer grinders were disposed of in the year 2000? So in the year 2000, we don't have sufficient data to give that value. So option D is the answer, cannot be determined from the data. Now let's look at the last question, question number 4. How many Purana mixer grinders were purchased in the year 1999? In the year 1999, 20 new purchases for Purana mixer grinders. So option A is the answer. I hope you understood how to do this question. We are going to learn about pie charts. As we can see, pie chart is a circle which is divided into different segments, and each segment according to its size represents a particular data value. So the question in front of us is a simple one, but we have two different graphs. Let's look at the question. Chart 1 shows the distribution of 12 million tons of crude oil transported through different modes. Chart 2 shows the distribution of the cost of transporting this crude oil. The total cost was rupees 30 million. So the first chart represents 12 million ton of crude oil which has been transported through different kinds of distribution modes. For example, through pipeline, 49% of crude oil was transported. So I hope you understood this chart. The second chart is cost of transportation. The colors represent the same mode as the first chart. Pipeline is represented by dark blue. And the overall value of the second chart is 30 million rupees. Let's draw a table which will make this question a lot more easier. So at the side of this table, let me write down the mode of distribution. First one is a pipeline represented by P, then ship, air freight, road, and rail. Now let's make two columns. First column is for volume and the second column is for cost. So let's fill up the data corresponding to the volume. So for pipeline represented by this dark blue color, it is 49%. So what is 49% of 12 million tons? So 49 divided by 100 into 12. Instead of using this, I would use 50% of 12 million means 6. And 1% refers to 0.12 million tons. So what I will do here is we have the value for a 50% which is 6 and I have the value for 1%, so I will just subtract it from 6. So 6 minus 0.12 is equal to 5.88 which is 49%. So you can find this value in the way that you prefer. So for pipeline, the volume is 5.88. Now the next one is ship, which is 9%. 10% means 1.2 million. So 1.2 million ton minus 0.12 will give us 9%, which is equal to 1.08. So 1.08. 11% means 1.2 plus 0.12, which is 1.32. Next one is rod. For rod, it is 22%, which is double of 11%. So all you have to do is double this value, 1.32, which is 2.64. The last value is rail is 9% again, which is 1.08. As you do more and more questions, you will find it easier to fill up the table or calculate this value is much easier. So now let's calculate the cost. The total cost is 30 million rupees. So 65% means 65 by 100 into 30. So all I have to do is to multiply 65 into 3 and divide by 10. So 65 into 3 is 195 and divide by 10 I will get 19.5. For ship it is 10%. 10% of 30 million rupees is 3 million. For air freight represented by green color, it is 7%, which means 2.1. 2.1. 6% means 1.8. Next one is rail, which is 12%. We have already found 6%, which is 1.8. So all you have to do is multiply it by 2. You will get 3.6. So now we have transferred all the data values from the two pie charts into this table. So we have filled up the table. Now let's try to solve the questions. Question number 1. The cost in rupees per ton of oil moved by rail and road happens to be roughly. So what is the total cost of transferring through road and rail? It is 1.8 plus 3.6. So it becomes 5.4 million rupees. The question asks the cost in rupees per ton. So you have to divide it by the total number of tons transferred. So it is 2.64 plus 1.08. 5.4 divided by 2.64 plus 1.08 will give you 3.72. So it is 540 divided by 372. If you have seen the video of a number system that I have covered in this channel, then you would know that these two numbers are divisible by 3. So 12480, 12490, and we get 62. Again dividing 45 by 31. So 45 divided by 31 is 1 minus 31. 14 point is 31 into 5, 31 into 4. Okay, 31 into 4, 1.4. So the closest answer here is option B, 1.5 is the answer. Question number 2. From the charts given, it appears that the cheapest mode of transport is. So how to find the cheapest mode of transport? You have to find the cost per volume of every mode of transport, and whichever is less will be the cheapest mode of transport. You can either divide each one of them, but it will take more time. So I'm just going to take a approximate figure. First one is a pipeline. 19.5 divided by 5.88 will give you about 3 point something. Next one is 3 divided by 1.08. Again slightly less than 3 is 2.9 or something. Next one is 2.1 divided by 1.32. It will give you 1.7 or something near. Next one is rod. 1.8 divided by 2.64. 1.8 divided by 2 will give you 0.9. So 2.64 will give you further less of a value. It will be 0.7 or something like that. Next is 3.6 divided by 1.08. Again 3.5 or closer to this value. So the cheapest here is rod, 0.7. No other value even come close to this one. So option A Last question, if the cost per ton of transport by ship, air and road are represented by PQR. Ship is represented by P, air is represented by Q, R represents road. So cost per ton is represented by PQR. Which of the following is true? So if you look at the approximate cost per ton we have already done, you can see that P is greater than Q is greater than R. So option C is the answer. We have seen that we have to convert the graph into a table to solve it quickly. We follow the same here in this question too. We will convert the line chart into a table and try to solve it. By converting the graph into a table, we are actually making it much easier for understanding and interpreting the data values in the question. If the question is simple, you can proceed even without the table. You can just mark it in the graph itself. Or if you have any other easier methods with you, then you should follow that. So now let's look how to solve this set. The line chart given represents year-wise birth and death numbers in millions. I have already drawn a table here. I will make two columns, birth and death, and will mark the year besides the table. 2001, 2002, 2003, 2004 and 2005. So let's fill up the birth column. So according to the line chart given, the number of birth in 2001 is 3.5. So in 2001 it is 3.5 million. In 2002 it rises up to 4 million. In 2003 it rises to 5 million. In 2004 it decreases to 3 million, and in 2005 it goes up to 6.5 million. Now let's fill up the death column, which is represented by the blue line. In 2001 it is 4.5, 2002 it is 5, 2003 it is 5.5, in 2004 it becomes 5, and in 2005 it rises up to 7. So all the available data from the line chart has been converted into a table. Now let's try to solve the question. Question number 1. Calculate the average number of births in the city between 2001 to 2005. So all you have to do here is to add up the numbers under the birth column and divide it by 5. So 3.5 plus 4, 7.5, 12.5, 15.5 and 16, 22. So 22 is the total. To get the average, you have to divide by 5. 22 divided by 5. So it is 4.4. Option C, 4.4 million is the answer. Question number 2. By what % approximately did the number of births increased in 2005 from the previous year? So number of birth in 2005 is 6.5 and number of birth in previous year 2004 is 3. So the difference is 6.5 minus 3 divided by the initial number of births, which is 3 into 100. So that becomes 3.5 divided by 3 into 100. 350 divided by 3. 1120. It is 6. Again 20666. Okay. So the answer is approximately option D, 117. Question number 3. Calculate the difference between the number of deaths and the number of births over the years. All you have to do is subtract the number of birth from number of death. So 4.5 minus 3.5 is 1. 5 minus 4, 1. 5.5 minus 5 is 0.5. 5 minus 3 is 2. And 7 minus 6.5 is 0.5. So you add it up, you get 2, 2.5, 4.5, 5. 5 million is the answer, option A. Now we come to the last question, question number 4. In which year the percentage increase in birth rate over the previous year was the maximum? So all you have to do is look at the numbers under the birth column. In 2001 it is 3.5, it increases to 4. So only an increase of about 0.5, which will only be an increase of about 20%. From 2002, it increases from 4 to 5. So it's an increase of 1, which is 25%. Now we come to 2003 to 4. It is actually a decrease, so you don't have to calculate that. In 2004 to 2005, it increases from 3 to 6.5. That is an increase of more than 100%, which is higher than any of the given value. So the question here is, in which year the percentage increase in birth rate over the previous year? So the year in which the percentage increase is more is 2005. Option D is the answer. This was a very simple question. I hope you understood how to read and solve a simple line graph. We are going to solve a stacked bar graph. A stacked bar graph is nothing but a bar graph in which multiple values are stacked on a single rectangle or bar. We will solve this question, then you will understand how to do it. This is a very simple question, so I am not going to convert it into a table. So the bar chart represents the number of workers employed by Megacorp Limited. There are two different sets of data here. Temporary, which is represented by blue, and orange color represents permanent. So for example, let's find out the temporary and permanent workers employed by the company in the month of April. April 1, temporary and permanent. The blue bar represents the number of temporary employees. So in April 1, there are 250 number of employees. 250. The number of permanent employees is from here to here. It is not 650, but it is 650 minus 250. So it becomes 400. So I hope you understood how to read the graph. Now let's try to solve the questions. Question number 1. By what percent did the number of temporary workers employed by Megacorp Limited increase from April 1 to May 1? We have already written down the values of April 1. So let's write down the values of May 1. The number of temporary employees is 350. And the number of permanent employees is 800 minus 350, which becomes 450. Actually, the given question does not ask anything about permanent workers, so you didn't have to calculate that. Anyway, the question asks what percentage did the number of temporary workers employed by Megacorp increase from April 1 to May 1. So the increase you can see 250 to 350. So 350 minus 250, which is 100, divided by the initial value, which is in April 1, which is 250 into 100. So that's how you find the percentage. You can divide by 50, 52520. So 40 percentage is the answer. Option A is the answer. Question number 2. What was the difference, if any, between the number of permanent workers employed by Megacorp Limited on March 1 and the number of permanent workers employed on April 1st? We already have the number of workers on April 1st. So the number of permanent workers on March 1st is 650 minus 300, which becomes 350. So the difference between 400 and 350 is 50. So option B is the answer. Question number 3. If on May 1, 60% of the permanent workers and 40% of the temporary workers employed by Megacorp Limited were women, how many of the workers employed by Megacorp Limited at the time were women? So we already have the data for May 1. 60% of permanent workers means 60 by 100 into 450. So 450 plus 40% of temporary workers, which is 350. So 40 by 100 into 350. So all you have to do is calculate this. You will get 6 into 45, which is 270, plus 0 get cancelled, and 4 into 35 becomes 140. So adding it, you will get 410. Option C is the answer. We have already done this question in this channel. So if you have watched it, no need to see it again, but try to solve it on your own. The following chart represents the number of students of IIMS Careers at its Lucknow Center who passed either the CAT exam or SAT or CET exam or none of these exams. Assume that there are no students who pass more than one exam. Okay, so there is no overlap. Let's look how it is done. In the year 2000, you have 20 students who have passed CAT. And then from 20 to 60, 70, 80, to 20 to 80, there is 80 minus 20, 60 students who passed XAT. 140 to 80, there is 140 minus 80, 60 students who passed CET. And yellow represents the number of students who have not qualified for any of the exams, which is 140 to 170. So 170 minus 140 is 30. Okay, so this is how you read the graph. So I hope you understood. Since this is a very simple question, I am not drawing the table. You can draw the table if you find the question to be hard. Question number 16. What was the percentage of students who cleared CAT in 2000? The blue color represents CAT. There is 20 students. 20 students who qualified for CAT. And what is so total number of students in 2000 is 170. So 20 divided by total number of students, which is 170 into 100. So 200 divided by 17. 1 minus 17, 301 minus 17, 130 becomes 17, 5s are 85, 92, 102, 119, 1197. So answer is 11.7, option D. Question number 17. What was the percentage of students who succeeded in at least one of the 3 exams? So you simply have to exclude the none part, the number of students who have qualified for none of the tests. So that is 30 in 2000. So that becomes 170 minus 30, 140. So 140 students have passed at least one of these subjects. So 140 divided by, total is 170 into 100. So it becomes 1400 divided by 17. 17 into 8 is 136. So 4. 17 into 8 is 146. So 402. 82. Alright. 34. Get 6. 0. 82. 17 into 3 is 51. 9. So 82.3. So option is C, 82.35. Question number 18. Which year showed the best result in MBA entrance exam for the institute in terms of percentage of students who cleared? We already have the number of students or the percentage of students who have passed in 2000, which is 82.35. In 2001, the number of students who have passed is, the total number of students is 180. Okay, 180. And the number of students who has not passed is 30. So 180 minus 30, 150. 150 students have passed. 150 divided by total number of students is 180 into 100. 0. 18 you can divide by 6. 3. 2. 305. 25. 250 divided by 3, which becomes 8. 103.33. So 83 in 2001 it is 83.33%. And in 2002, the total number of students is 200. The number of students who has not passed is 40. So 200 minus 40 is 160 divided by total number of students, which is 200 into 100. That becomes 280. So in 2002, it is 80%. So the best result happened in the year 2001. So option B is the answer for question number 18. Question number 19. What is the percentage increase in the number of students in 2002 over 2000? So in 2002, the number of students is 200. In 2000, the number of students is 170. So from 2000 to 2002, the increase is 200 minus 170, 30. The number of students in the year 2000 was 170. So 30 divided by 170 into 100. It becomes 300 divided by 17, which is 117. 13 0. So it will become 17 into 7, which is 119 11 7. So the option here is 17.64. Option B. Option B is the answer. Bar chart, pie chart, line charts and other DILR graphs have already been covered. We are going to look at DILR caselets. Instead of giving diagrams and graphs, they will convey the data or information to a paragraph or to a list of points. You have to find out the relevant points, sort them out and solve the questions. Let's look how it is done. Question. On the basis of the information given below, select the correct alternative as answer for the questions which follow the information. 6 plays A, B, C, D, E and F are to be staged, one on each day from Monday to Saturday. The schedule of the plays are to be in accordance with the following information. So we have to read these points and from that we have to solve the question. So let's make it into a table. We'll draw it like this. We will write the information inside this diagram and days here: Monday, Tuesday, Wednesday, Thursday, Friday and Saturday. First point is A must be staged immediately before E. So let's represent it by writing A and E together. Alright, A and E is together. Second, C must not be staged on Tuesday. So C cannot be here. Third point, B must be staged on the day after the day on which F is staged. We represent it the same way we have done for A and E. B must be staged on the day after the day on which F is staged. So F, B. Point number 4, E must not be staged on the last day of the schedule. So on Saturday, E should not be scheduled, which automatically means A cannot be here on Friday because A and E are always together. Point number 5, D must be staged on Friday only. So we get the corresponding day for D, which is Friday. We will circle it so that we know that this is the right answer, D. Now the next point is D must be staged on Friday only, and immediately before D, B must not be staged. So B can't be here, which automatically means F cannot be here too, since F and B is together. So we have run through the 5 points and the table is right now in this condition. So what is the next step? So let's take FB first. We know that B cannot take place on Thursday and we know that B cannot take place on Saturday, because if B is here then F should be on Friday, which is not possible. So now we have only 2 options left, either Tuesday or Wednesday. Let's look if we can conduct B on Wednesday. So B is here, which means F should be here. And now comes the next problem. We have A and E and we have no 2 slots available together. So which means our assumption of B on Wednesday is wrong. So our last option is to put B on Tuesday, which means F is on Monday. Now E will automatically fall on Thursday and A should be on Wednesday. So the remaining play here is a C, so which will be conducted on Saturday. So the final order of plays is F, B, A, E, D, C from Monday to Saturday. I hope you understood how it is done. Now let's solve the questions. Question number 1. Which of the following plays staged immediately after E? D is the answer. Which of the following plays are staged on Monday? On Monday, F was staged. Play F is the answer. Question number 3. Play D is between which of the following pairs of plays? It is E and C. C and E is the right answer. Last question. Which of the following is a schedule of plays with the order of their staging from Monday? It's from F, B, A, E, D, C. Not these, so the answer should be none of these. I hope you understood how to solve this question. We will practice more DILR sets in the coming videos. Let's read the question. 1,000 patients currently suffering from a disease were selected to study the effectiveness of treatment of 4 types of medicines A, B, C and D. These patients were first randomly assigned into 2 groups of equal size. So there were a total of 1,000 patients and they divided into 2 groups of equal size. So equal size means 500 and 500. Treatment group and control group. So first group is called treatment group and the next one is control group. The patients in the control group were not treated with any of these medicines. Instead they were given a dummy medicine called placebo containing only sugar and starch. The following information is known about the patients in the treatment group. So the 500 people in the control group does not get any kind of medicines A, B, C or D. Only the remaining 500 in the treatment group will receive the medicines. So in real world, this is exactly how you conduct a vaccine trial. You select a group of patients and then divide it into 2 groups. One of the group is given placebo and the other group is given regular medicine or vaccine, whichever they are testing. You can read more about it. So let's come back to the question. Following information is known about the patients in the treatment group. So we have A to F. All of these informations are about the 500 people that is present in control group. Take some time to read the points. First point is a total of 250 patients were treated with type A medicine and a total of 210 patients were treated with type C medicine. So if you look at all of these points, you can see that different numbers are thrown around. So before proceeding, I need to explain another theory to you. Let's look at that first. So this question is actually based on set theory. So for example, if there were 2 types of medicines A and B, then we would have drawn a circle to represent both of them, A and B. This part will represent medicine A only and this part will represent medicine B only, and this will be intersection between A and B, which means both A and B medicines are given, and everyone outside this, that means all these areas will be treated as people who did not get any of medicine A and B. But in our current problem, there are actually 4 medicines A, B, C and D. For example, some people may get both the medicines A and B, or some others may get only B and C, or C and D, or some of them will receive A, B, C and D, and so on. There are about 15 different possibilities. So what can we do here? So instead of using circles to represent each sets, we will make use of a different diagram. I will show how it is done. So these are basically projections and each projections represents A, B, C or D. So first projection, second one was like this. Third one will be like this, and fourth one. So the first projection represents A, second one B, third one C and fourth one D. If you look at this image, you can see that the whole of the diagram is divided into 15 different partitions. 4 here, 4, 4, 12 plus 3, 15. So what does each partition represents? For example, this partition contains the number of people who have received the medicine D only. Now this one represents the number of people who have received only medicine C. So let me ask you a couple of questions. Which one of the partitions represent the number of people who have received both A and B only? So that will be this one. Another question, which of the partition represents the number of people who have received A, B, C and D, all the medicines? This partition represents all the number of people who have received A, B, C and D. If you look, you can see that it is part of A, it is part of B, it is part of C and it is part of D. Let's look at one more. Number of people who have received A, B and C will be included in this partition. And all the people who have not received any of these medicines A, B, C or D will be represented outside this diagram and within this universal set. I hope you understood this. We will apply this in the current question and you will get a better idea of it. I request you to try and draw the diagram on your own. If you are not able to draw it, then go back and see the video. Make sure you draw it on your own. Otherwise, it is very likely that you will forget soon. Okay, so this is our diagram. We have 4 different medicines, A, B, C and D. So the total number of patients were 1000. So we will represent that 1000 using this universal set, which you can represent it here. And they are divided into 2 equal parts. So 500 patients will be control group, and all the control group are outside this projection diagram. So 500 people here, and the rest of the 500 people will be within these A, B, C and D projections. So let's read each points one by one and try to mark as much as we can. A total of 250 patients were treated with type A medicine and a total of 200 patients were treated with type C medicine. Now we will read through each points. The first point, a total of 250 patients were treated with type A medicine. So this projection here represents A, and the 250 value represents the whole of projections from here to here. So we will write down the value along with A. I will write it here 250, and this 250 is represented by whole of this projection. And a total of 210 patients were treated with type C medicine. So again type C is represented from here to here. Whole of this projection is type C. So we will write 210 here, just below C. Second point, 25 patients were treated with type A medicine only. So this partition which does not include B, C or D represents A only. So 25 we will write it here. 20 patients were treated with type C medicine only. So this portion represents C only, 20 here. 10 patients were treated with type D medicine only. So 10 here. The next point, 35 patients were treated with type A and type D medicines only. A and D only is represented by this partition. So we will write 35 here. 3, 5. 20 patients were treated with type A and type B medicines only. So A and B only is represented by this partition. We will write 20 over here. 30 patients were treated with type A and type C medicines only. A and C is represented by this partition. So 30 here. 20 patients were treated with type C and type D medicine only, which is this one. So we write here 20. So we move on to the next point. 100 patients were treated with exactly 3 types of medicines. For example, A, B, C. There are 3 types of medicines. All the people who have been treated with A, B, C is included in the group. But it is not over. You have to add all the different medicine combinations. Next possibility could be A, C, D, A, B, D. Next possibility is B, C, D. So these are the 4 possibilities, and this is equal to 100. So let me just mark these 4 partitions in the diagram. A, B, C only will be this one. So I will name it as U. Next is A, C, D. A, C and D only will be this one. So I will name it as V. A, B and D only will be this one, W. B, C and D is this partition. I name it as X. So I will just note it down here. U plus V plus W plus X is equal to 100. Next point, 40 patients were treated with medicines of types A, B and C, but not with medicines of type D. So there are 3 medicines, A, B and C, which is actually represented in this diagram using the letter U. So U is equal to 40. We will write it here too. The rest of the point says 20 patients were treated with medicines of types A, C and D. A, C and D. So again we got the next letter. V is equal to 20. V is equal to 20. Now going to the last point, 50 patients were given all 4 types of medicines. So A, B, C and D only is represented by this partition. So I'll write 50 here. 75 patients were treated with exactly 1 type of medicine. So what does that mean? A only or B only or C only or D only is equal to 75. Total is 75. If you look at the diagram, you can see that A only is 25, B we don't know, C only is 20 and D only is 10, equal to 75. So B will be equal to 30 plus 25, 55. 75 minus 55, which is equal to 20. So we can write the value of B only as 20 here. Also let's substitute the value of U and V in equation number 1. U is 40, V is 20, 60. W plus X is equal to 100 minus 60, that is 40. I will mark this as equation number 2. We will use it later on. So if you remember our first point, the total number of patients who have taken medicine A is 250, as we have written down here. And for C it is 210. So we have those values too. So let's try to form an equation and solve this question. Okay, so we are taking all the values of A. A will be equal to 25 plus 20 plus 30 plus 40 plus V, that is 20, plus 50 plus 35 plus W. Okay, and the value of A we know it as 250. So 250 is equal to, let's add all these numbers, 25 plus 20, 45, 75, 115, 135, 185, 190, 220. So 220 plus W is equal to 250 minus 220, which is 30. So we got the value of W as 30. which means we can substitute it in equation number 2 and get the value of x as 10. So we got another value, let's write it here, 10, and w is equal to 30. Now before proceeding, let's look at the first question. The first question says how many patients were treated with medicine type B. The question is not to find the medicine type B only, but you have to find out the whole value inside the projection of B. So which means you have to find out the value of this partition and this partition. So let's try to find out. So how can we do that? We have the value of C, so the rest of the part is easy. So let's name this partition as Y. So whole of this C partition will be equal to 210. 30 plus 40, 70, 70 plus 20, 90, 110, 120, 170, 190 plus Y. 190 plus Y is equal to 210, which means Y is equal to 20. So we'll write the value of Y as 20 here. And now we have to find out the value of this partition. Let's name it as K. So how can you find out that value? You already know that there were 1000 patients in total and it was divided into 500 were in control group and 500 were randomly taken for treatment. So which means the whole value of the partition will be equal to 500. So all you have to do is add up these values and equate it to 500. You will get the value of K. So to find that out, the whole partition of A contains 250. So 250 plus, we have already added this one. So we will add 20 plus 20, 40 plus 10, 50 plus K. 50 plus K plus 20 plus 20, 40 plus 10, 50 is equal to 500. So when you add up, you will get 350. K is equal to 500 minus 350, which is 150. So the value of K is equal to 150. So now let's look at the questions. Question D1, how many patients were treated with medicine type B? So you have to find out everything that comes under B. If you add it up, it will be 160, 200, 260, 300 and then 340. So the answer for first question is 340. Let's look at the remaining. D2, the number of patients who were treated with medicine types B, C and D but not type A. So B, C and D but not A will be X is equal to 10. So the value is 10. Next question, how many patients were treated with medicine types B and D only? B and D is represented by this value, so K. So the answer is 150. And the last question, the number of patients who were treated with medicine type D. So again, you have to find out the total number of patients within the projection D. It will be 70, 80, 100, 110, 260, 290, 325. So answer for question number D4 will be 325. So I hope you understood how to solve this question. If one of these questions come, all you have to know is how to draw this diagram and the rest of the things will be easy. We will now solve different DILR sets in the coming videos to get more practice. Remember that all the topics we have covered can be clubbed together to form tougher questions. A pie chart and a bar graph can be given together and so on. Stay safe and I will see you in the next video.